Approximately every 11 years, our sun experiences a cycle in which its magnetic poles flip. During this cycle, solar flares and sunspot activity increase, and then the sun returns to a state of relative calm. These solar cycles have been tracked for over 200 years and are among the best recorded aspects of solar astronomy. These extremes, known as solar maximum and solar minimum, affect the sun and can also have implications for us on Earth. Learn more about the solar cycle and the ebbing and flowing of the sun on this episode of Everything Everywhere Daily. This episode is sponsored by NerdWallet.
Nerds!
When it comes to general knowledge and history, you know I've got you covered. But who do you turn to when you need smart financial decisions? If your answer is NerdWallet, then you're absolutely right. And if it's not, let me change your mind. The nerds at NerdWallet have spent thousands of hours researching and reviewing over 1,300 financial products. And they have the tools you need to make smarter financial decisions. Looking for a credit card? Go beyond the basic comparisons, filter for features that matter to you, and read in-depth reviews. Ready to choose a high-yield savings account? Get access to exclusive deals and compare rates, bonuses, and more. House hunting? View today's top mortgage rates for your home sweet home. Make the Nerds your go-to resource for smart financial decisions. Head to nerdwallet.com/learn more. NerdWallet. Finance smarter. Disclosure: NerdWallet Compare Incorporated, NMLS 1617539.
What do Mattel, Banana Republic, ButcherBox, and Glossier all have in common? They power their businesses with Shopify. Shopify is the most innovative and scaled commerce platform on the planet that also happens to have the best converting checkout on the planet. And that's no industry secret. That's Shopify. Learn more at shopify.com/enterprise.
The sun isn't just the center of our solar system. In many ways, it's the beating heart of the solar system. The sun is ultimately responsible for all life on Earth, including all of our weather and the fact that we have liquid water. If the sun were to stop shining, the Earth would be nothing but a frozen ball in the darkness. The sun, however, isn't some cosmic light bulb steadily burning in the sky. It's alive with activity, sometimes violent activity, the scale of which would dwarf our planet. In a previous episode, I covered the basics of the sun, what it's composed of, and how it functions. In this episode, I want to focus on just one aspect of the sun, the solar cycle. This cycle lasts, on average, 11 years, and is associated with fluctuations in sunspots and solar flares. Despite being the most obvious thing that we see in the sky, our knowledge of the sun was shockingly scant for most of human history. We knew more about the movement of stars and planets than we did about the sun, simply because it was too bright to ever observe directly. That being said, ancient astronomers occasionally observed sunspots, with records dating back to at least 800 BC in China. However, these observations were sporadic and not understood in the context of a cycle. Galileo Galilei and several contemporaries, equipped with newly invented telescopes, made the first systematic observations of sunspots. Their discoveries challenged the then prevailing Aristotelian cosmology that held that celestial bodies had to be unchanging and perfect. These sunspots were assumed to be random events for several centuries. It wasn't until 1843 when Samuel Heinrich Schwabe, a German astronomer, announced the discovery of a regular cycle in sunspot numbers. After 17 years of diligent observations, Schwabe noticed a periodic variation in the number of sunspots, suggesting a cycle of approximately every 10 years. This discovery initially went unnoticed by the broader scientific community. In 1848, Rudolf Wolf, a Swiss astronomer, started systematic observations and developed the sunspot number index, which is still used today. He reconstructed historical sunspot numbers back to the year 1700 and improved upon Schwabe's estimate of the average solar cycle length by pinning it at 11 years. In 1852, a British astronomer, Edward Sabine, linked the solar cycle to geomagnetic activity on Earth. He noticed that the geomagnetic disturbances observed on Earth seemed to follow the same cycle as the sunspots. A big breakthrough in our observation of the sun took place in 1859. British astronomer Richard Carrington observed a solar flare directly associated with a major geomagnetic storm on Earth, now known as the Carrington event. The Carrington event, which I covered in a previous episode, caused global telegraph systems to fall, sparked widespread auroral displays, and demonstrated the profound impact solar activity can have on technological systems. By the end of the 19th century, sunspots and solar flares were a well-known phenomenon, but nobody really knew what caused them. The big breakthrough in that department came in 1908, when George Ellery Hale and his colleagues at the Mount Wilson Observatory used the newly developed spectroheliograph to discover magnetic fields in sunspots, suggesting that the solar cycle was a magnetic phenomenon. Finally, in 1955, American astronomer Horace Babcock proposed the model of the solar dynamo, which provided a theoretical explanation for the generation of the sun's magnetic field and its cyclical nature involving differential rotation and convection in the sun's interior. Since the dawn of the space age, our understanding of the sun and solar cycles has increased dramatically. In the late 20th century, observations from space-based observatories like Skylab, the Solar Maximum mission, and the Yohkoh satellite provide new insights into solar phenomenon linked to the solar cycle, including solar flares and coronal mass ejections. In the 21st century, the Solar and Heliospheric Observatory, or SOHO, the Transition Region Coronal Explorer, TRACE, and the Solar Dynamics Observatory, SDO, have provided continuous, high-resolution observations of the sun, significantly advancing our understanding of the solar cycle's impact on space weather and solar-terrestrial relations. So, with all that we've learned about the sun, what exactly is going on? What is the cause of the solar cycle, and by extension, sunspots and solar flares? As George Ellery Hale figured out over a century ago, it all has to do with magnetic fields. As all of you know, the Earth has a magnetic field. The Earth's magnetic field is generated in its outer core by the geodynamo process, where the movement of molten iron and nickel generates electrical currents. This process is driven by the heat escaping from the core and the rotation of the Earth. Because of how it's created, the Earth's field is relatively stable over human timescales, although it does experience gradual changes and reversals over geologic timescales, in the order of hundreds of thousands to millions of years. The field generally maintains a dipolar configuration with magnetic north and south poles aligned close to the geographic poles. Although the analogy isn't quite accurate, you can sort of think of the Earth's magnetic field as similar to that of a bar magnet with a permanent magnetic field. The sun's magnetic field works totally differently. The sun is made up almost entirely of hydrogen and helium, which are non-magnetic elements. If the Earth is like a big bar magnet, then the sun is more like an electromagnet. The sun's magnetic field is generated primarily in the tachocline, a thin layer between the sun's radiative and convective zones. Here, the differential rotation between the faster rotating equator and the slower rotating poles, and the convective motion of plasma, interact to create and sustain magnetic fields. The tachocline of the sun is located approximately 200,000 kilometers or 125,000 miles beneath the sun's surface. It lies at the interface between the outer convective zone and the deeper radiative zone. The thickness of the tachocline is relatively thin compared to the sun's overall radius. It spans about 3 to 5% of the sun's radius, translating to roughly 20,000 to 30,000 kilometers, or about 12,400 to 18,600 miles. Through a process known as the solar dynamo, the motion of electrically charged plasma generates these magnetic fields. The process involves converting kinetic energy from plasma motion into magnetic energy. The magnetic fields are constantly created, twisted, and reconfigured due to the sun's differing rotations and the turbulent convective motions in its outer layers. Because the sun's magnetic field comes from a thin layer close to the surface rather than the core, the result is a very different type of magnetic field than what we have on Earth. Unlike the Earth's magnetic field, which is very stable, the sun's magnetic field is relatively unstable. All of the twisting and distorting of the sun's magnetic field lines brought about by shearing in the tachocline is the source of the solar cycle. As these magnetic field lines become twisted, they can result in solar flares and sunspots. Solar flares are intense bursts of radiation resulting from the release of magnetic energy. Sunspots are created by magnetic activity that inhibits convection by exerting strong magnetic pressure, leading to cooler, darker areas on the sun's surface. These spots appear as dark patches because they are cooler than the surrounding areas, resulting from the concentration of magnetic field lines that prevent transportation of heat from the sun's interior to its surface. A solar cycle begins at a solar minimum, where few sunspots and solar flares are visible. Activity then increases to a solar maximum, typically within about 5 to 6 years from the minimum, before decreasing back to the next minimum. The number of sunspots that can be seen is a proxy for the intensity of the sun's magnetic activity. The average cycle time is 11 years, although cycles have been completed in as few as 8 and as many as 14 years. Technically, it actually takes about 22 years for the sun's poles to return to their original orientation, but because the orientation of the poles really doesn't matter with regards to the effects of a solar cycle, 11 years is usually the way the cycle is tracked. So, what does this solar cycle mean for us on Earth? Increased solar activity can lead to more intense solar flares and coronal mass injections, disrupting satellite operations, GPS navigation, and radio communications. And they can also pose risks to astronauts from increased radiation levels in space. Solar flares produce enhanced levels of solar radiation, including ultraviolet and X-ray emissions, which significantly ionize the Earth's upper atmosphere. This increased ionization can create denser and more reflective ionospheric layers, which are used for high-frequency radio wave propagation over long distances. Likewise, during solar minimums, high-frequency radio signals can't travel as far. So, for the most part, ham radio operators love solar maximums. Solar maximums also enhance auroral activity, leading to more frequent and vivid displays of the aurora borealis, aka the northern lights, and the aurora australis, aka the southern lights. What's really interesting is that scientists have been able to reconstruct solar cycles going back over 10,000 years by using indirect proxy data. Carbon-14 is created in the upper atmosphere primarily through the interaction of cosmic rays from outer space with nitrogen atoms. Solar activity influences the flux of cosmic rays reaching the Earth's atmosphere, because higher solar activity results in a stronger solar wind that deflects more cosmic rays away from the Earth, reducing the production of carbon-14. So by measuring carbon-14 concentrations in dated tree rings, scientists can infer changes in solar activity, with lower carbon-14 levels corresponding to higher periods of solar activity. Similar to carbon-14, beryllium-10 is produced by cosmic ray interactions, this time with oxygen and nitrogen. It becomes attached to aerosols in the atmosphere, eventually depositing on the Earth's surface and becoming trapped in polar ice sheets. By analyzing beryllium-10 concentration in ice cores, which can be dated with annual layers, particularly in Greenland and Antarctica, scientists can reconstruct variations in solar activity. Higher concentrations of beryllium-10 typically indicate lower solar activity. These techniques have found that solar maximums have been at their highest levels in over 2,000 years since the Second World War, with exceptionally high levels occurring about 11,000 years ago. Using these and similar techniques on fossils, researchers estimate that the current solar cycle of 11 years has been stable for at least the last 700 million years. So even if you don't pay attention and aren't aware of it, the solar cycle plays an enormously important role in our lives. It's the pulse of the sun that does everything from disrupt radio communications to creating mind-blowing northern lights. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.